Hello everyone. In this video, let us discuss about pipelining organization and its issues. So, before getting into the pipelining organization, let me give an introduction to pipelining. So, actually, what pipelining is, it enhances the instruction throughput by processing multiple instructions simultaneously. Here, the execution is divided into distinct stages, and because of this division, it will improve the efficiency. So, at each stage, completes a part of instructions, allowing to overlap. So, let me illustrate this with an simple example so that you guys can understand. So, let us take an example of an a restaurant. Okay, so in restaurant, say three persons are coming: person A, person B, and person C. So let the order of arrival be A comes first, and then B comes, and then C arrives. So okay. So basically, once we get into the hotel or something, what we will do is we will place the order, and it will be get prepared, and it will be delivered one, and then we eat and we leave. So first step will be we will order something, and it will be prepared by the chef. After preparation, it will be delivered. It will be delivered to our table. Once it get delivered, we will eat it. Order, prepare, deliver, and we will eat, and then we will leave. So uh, this is one of the simplest um, thing what happens in a restaurant. So these five stages. Say person A arrives. So now let us think of a scenario where pipelining does not exist. What happens if pipelining is not there or not followed? Person A comes and he will uh, ordered, and it will be get prepared. So by the time B will arise and he will wait, and person A's order will be prepared and it will be delivered. So delivered to the A. By that time C arrives, and he will also wait. And after delivered, A will eat and A will leave. So after leaving, the waiter comes and takes take the order of B, and the B's order will be prepared, and it will be delivered, and it will be eaten by B, and he leaves. So similarly happens for C. So this is what happens when there is no pipelining involved. So let us now illustrate the example when pipelining is there. Similarly, three persons come to the hotel and order, and then once ordered, it will be prepared. It will be prepared, and it will be delivered, and the person will eat, and he will leave. So this is what happens. And one in the world of pipelining, person A orders the food, and the person A's order will be prepared. By the time B's order will be taken by the waiter. So once the A's order get prepared, it will go to the deliver space. When that phase occurs, C will be arrived, and B's order goes to preparation phase, and C's order will be taken. Then person A's order will once it delivered, he will start seating. By that time, B's order will be ready for get delivered for delivery, and C's order goes to preparation phase. And once person A eats, he will leave. When he leaves, B's order will be eaten by the B, and the C's order goes for delivery. Then finally, similarly, after all these steps, A leaves, then B leaves, then C leaves. So here, what is the advantage you can say? Actually, the here, say for example, the main salary we are giving to is uh, the waiter and the chef. So here, when there is no pipelining involved, the waiter and also the input persons B and C and cook remains idle when during eating time, and delivery time, the waiter will go and deliver the food, but the chef will remain idle. So it causes wastage of money, and efficiency will be not there. So to prevent this, we are using pipelining. In pipelining approach, everything happens in a sequenced manner, and once instruction is executed, when it is in, say, it's stage 2, the next instruction will be in stage 1, and similarly it goes to stage 3, 4, 5. That will, I will explain it later. So this is the one of the basic example through which you can understand what is pipelining and what it does. Okay. Now, coming back to the big business, let's discuss the what pipelining is and pipelining organization. Let us discuss the pipelining organization. So actually, it contains 5 stages. So fetch stage, decode, compute, memory, write back. In fetch stage, the instruction is received from the memory, so it is fetched from the memory. And in decode, the instruction that is fetched is decoded, and it is determined what operation must be performed for on the data. So after that, there is a phase called compute. In that, the execution is performed using ALU, arithmetic logical unit, and after computation, if memory access is required, uh, in case of writing back to memory, if access is required, memory access is granted. Once access is granted for reading or writing, in case of writing, it is written back into the registers. So on between each of these stages, five stage pipeline model, there are interstage buffers called B1, B2, B3, and B4, which holds the data between stages, because we need buffer so that when another new instruction comes, it will be stored in the buffer, and it will be it will be in wait state till when it will be in wait state when till one of the instruction completes and it moves on to the next stage. Okay, so now let us see the diagram. So here, actually, uh, this is fetch. So uh, the instruction is fetched from the memory, and it is stored in the interstage buffer, and it is stored in the interstage buffer. And once there is actually this buffer acts like a queue. It will be queue. It acts like a queue. So once the instruction comes, it will be stored in the buffer, and it will be sent to the instruction decode. When the decode is free, here the instruction will be decoded, and it will be stored. It will decoded, instruction is fetched, and it will stored in the interstate buffer B1. And after that, it goes to the second phase called instruction decode. Here, what the fetched instruction is decoded, and it is determined what operation must be performed, whether it is addition or incrementation or decrementation. Whatever instruction may be must be performed, it is decoded. And here there is another register which comes into the picture called register file. So actually, from register files, the required data is passed to the uh, instruction, is passed along with the instruction. Once the instruction is decoded, it goes to compute stage. So in computation of instruction, uh, the ALU's uh, main big boy here, who performs the computation tasks and such that. And once it is computed, it goes to interstage buffer 3, and after that, memory access is done, and it is stored. Those results are stored in buffer B4, and again, note the point, it is again going to the register file. So this happens when there is an instruction called A plus B. Here the A is fetched and it is decoded and it is loaded for computation purpose. So the instruction comes and it is compute for computation purpose it is done. So the register file needs a operand called B. So with B only it can proceed. So for storing B after this C only the register file B will be. Let me explain this from first so that it will be understand you much better. So simple operation solved addition A plus B minus C plus D. Okay. Here, first the instruction is first the what happens is that the instruction is fetched from the instruction occurs and it is stored in the buffer B1 and the instruction is decoded. Here, this one step we all know that it can be written in the it's called as load A, load B, then add A comma B, and then store it in a variable called C. So these are the instruction that will be performed and it will be fetched and decoded. The A will be loaded and here the computation is nothing but the computing the address of the A and it will be buffer stores the address and it will access the memory and it will be stored in the register file. So what happens is that the instruction is fetched from the memory. The instruction fetch occurs and it is stored in the buffer B1 and after that it goes to the second stage called instruction decode and once the instruction that is given is decoded and what it has to perform is determined, it is again stored in interstage buffer B2 and then it goes for computation and it is stored in buffer B3 and again it accesses the memory and again it's stored in the buffer B4 and again if needed it is sent to the register file and stored in some registers called RA, RB, RZ, RY, etc. So these are the registers. So you may ask why there is a need of buffer. So for this say for example one program is executing and it is say the one instruction is in decode phase decode stage. Say one command is executed and it is in the decode stage. In that time, another command is fetched and it cannot be decoded here. So it is stored in the buffer B1, which is nothing like but a queue data structure where it will stored in the queue buffer B1 buffer queue and once here it is completed and it moves on to compute stage, then only the buffer b the command from buffer b1 will goes to the instruction decode stage. So similarly it occurs for everyone, so that is only that is why there are interstage buffers b1 b2 b3 and b4. So actually here there is a concept called control signals. So for each stage there is a control signal uh, which controls that execution stage. So also source and destination registers identifiers and other informations are also passed along with the data. Okay. Now, I already explained about the pipeline operation. So it enables simultaneous execution of multiple instruction can be executed in sequential manner. So there is the main point that that we are focusing here on is the utilization of the CPU. So the pipeline in this operation, we are mainly focused on the utilization of the CPU. So which enhances the throughput and also efficiency of the CPU. Ultimately it enhances the performance. Okay, now let us discuss what are the issues that can occur in pipelining. So till now we have discussed about pipelining and its organization. Now let us discuss what are the drawbacks that may occur in case of pipelining usage. Okay, so there are three assets that can occur. So one is the data asset, control asset, and structural assets. So data assets are nothing but the dependencies between the instructions. So instruction is depend on another instruction. Control assert is nothing but delays due to branch instruction. There may be a cause of delays. So that is nothing but the control asserts, and structural asserts are the hardware conflicts that we will discuss in upcoming slides. Okay, data assets. So data assets is nothing but when it occurs when the instruction depend on previous instruction results. So actually, say for example, there is an instruction called A, and this for this to execute, it depends on some register value called B, which will be updated only when current execution completes. So, if two instruction comes in parallel, A and B can even though B is in B can go to the compute stage, but it depends on A. So one for A to occur, we need a B. Okay, that is the concept. So for that, the B's value must be updated. So the A has to wait. So this phenomena of waiting, making the wait pause temporarily is called stalling. So this is the data set that can occur. So how can we, what are the solutions for that? We can use operand forwarding, or pipeline must be stalled. So delaying the execution temporarily is the only solution, or we can also follow something called operand forwarding. It is nothing but, so it means that it is nothing but we all know that a register value will be updated only after the last stage write back. So when we use some techniques to make those changes before that stage, and using those results early, so that process is called operand forwarding. Okay, now let me discuss about the control asserts. So these arise due to the branch instructions affecting the instruction flow. The pipeline stalls until the branch decision is confirmed. So it occurs due to some of the decisions made by the branch instruction. So how can we prevent it? It can be prevented by branch prediction, predicting what the outcomes of the branch, and delayed branching. So it is scheduling useful instruction before branch resolution. Okay, coming to structural hazards. So here it occurs because instruction A, say command A and command B, it requires same resource. So it has to wait till one of which completes its execution and it moves on. Then will be the second instruction will be allowed to enter. So how can we, this is called structural assaults. This is also one of the issue of pipelining. We can solve it using hardware duplication. For example, if two program simultaneously give print to the printer, if there are only one printer, the program, say the program one executed printer one, so it has to program 2 has to wait till the printer access is completed, and it is print the document accessed by the printer one. Program 1 is printed on the printer, then only the program two's document is printed. So how can we reduce it, or how can we um, what are the solutions for that? We can use two printers, that's it. Also we can use something called instruction scheduling. That is efficiently we are crafting the instruction arrangement so that it does not know two instructions simultaneously asks for the printer. So that is one of the aside. Say my friend is going, say we are going to watch a movie and there is only one ticket counter. So which because of this, since there is only one ticket counter, if many people come, they have to wait in long queue. This is one of the example for structural assault. There is only one hardware available for computation. So that is one counter. Say a person is when he's booking ticket, his UPI payment is get failed and it gets delayed. So because of his delay, the remaining persons must wait. They have to wait till the person one completes his payment. So this is one of the example for data hazard. Say okay, everything is going clear, and say the person suddenly he changes his mind, and does not watch movie. So because of his sudden decision, it goes straight. This is one of the example for controller search. So that's it. Again, these are the issues. So the techniques we are following are operand forwarding, branch prediction, pipeline interlocks, automatically, and speculative execution. So these are the uh, ways to prevent pipelines issues. So conclusion, at the end of the day, what the the main thing is what pipelining does. It improves the throughput in model processors, and it improves the uh, performance. And hazards can impact performance, but it can be mitigated, or it can be prevented by using the following techniques that I discussed above. So in this slide, what we discussed is what pipelining is. I gave a brief introduction about pipelining and what pipelining is, and we discussed about the organization. So the the five major stages of pipelining: fetch, decode, compute, and compute, memory, write back. So these five stages we discussed, and then we saw the diagram of the organization of pipeline, and we came to pipeline. What are the issues that can be caused by pipelines? So we call those are called three. There are basically three issues. So data hazard, control hazards, structural hazards. So I also discuss how it can be prevented by giving some solutions like operand forwarding, stalling, and etc. So also stalling is a phenomena where the execution gets delayed temporarily. It gets temporarily stopped, and the it is delayed. So that phenomenon is called stalling. And after that, I discussed a real life scenario for analogy for you to understand. So that's it about the concept of pipelining and its organization and issues of pipelining and how to prevent this. So I hope this video is useful to you. So I thank everyone for watching this video. For more such useful content, consider subscribing. Thank you.